our theoretical models wrong, or is it the universe? Well, the answer is obvious. The James Webb Telescope has now recorded a whole series of mysterious discoveries that contradict conventional cosmology. But what revolutionary knowledge can be derived from these impossible structures? Are our assumptions about the age and origin of the cosmos still tenable, or do we now have to admit that we have been on the wrong astronomical track for decades? The exploration of the universe is subject to constant change, and this change has led to many interesting developments in the past. Just think of the worldview of our distant ancestors, who were firmly convinced that the Earth was the center of the universe around which all other celestial bodies revolved. Well, it is possible to be wrong. Today, of course, we know that our earthly home is just a tiny mosaic piece in a colossal overall picture that we have by no means deciphered. And yet, it seems that every new discovery must first overcome a few internal hurdles. Want an example? Although Edwin Hubble had recognized that practically all observed galaxies were moving away from us, Albert Einstein clung so strongly to his image of a rigid, unchanging universe that he added the cosmological constant to his field equation. Looking back, we can say that Einstein later corrected his mistake, calling it the greatest blunder of his life, and that the galaxy movements identified by Hubble were related to the relentless expansion of the cosmos. According to our official knowledge, this expansion process did not just begin yesterday but around 13.8 billion years ago with the Big Bang. Contrary to initial assumptions, however, this process does not describe a huge explosion into existing space. Instead, it describes the rapid expansion of space itself from an original singularity. Matter and time also emerged from this tiny, hot starting point. But how can we even know this today? Well, quite simply by looking backwards at the corresponding development. In this way, it is possible to calculate back to a point at which the density of matter and energy becomes infinite and all spatial distances become zero. Another outstanding proof of the correctness of the Big Bang theory is the detection of cosmic microwave background radiation. This relic from the time shortly after the creation of the universe is almost isotropic and fills the entire universe. So far, so generally accepted. But how do you deal with discoveries that simply cannot be reconciled with the Big Bang theory and the findings based on it? The cosmological consensus is that the first stars were formed 200 to 300 million years after the Big Bang, and that the first galaxies were still astronomical dwarfs. No wonder, after all, there simply wasn't enough normal matter back then to form full-blown galactic giants. Well, at least in theory. But since the cosmos doesn't seem to be particularly interested in our theoretical models, last year the James Webb Telescope detected something that strictly speaking shouldn't even exist: the impossible galaxies. Astrophysicist Ivo Lahr and his team at Swinburne University of Technology in Melbourne had analyzed some images from the near-infrared camera, NIRCam, from the early release program of the James Webb Telescope. The images showed a section of the sky near the Big Dipper, which is commonly known as part of the dawn of the universe. And indeed, it didn't take long for Lahr to realize that he and his colleagues had just detected something extraordinary. He described the initial reaction to the groundbreaking discovery as follows: "I run the analysis software and it spits out two numbers, distance 13.1 billion years, and mass 100 billion stars. I almost spit out my coffee. I knew we had just discovered the impossible, impossibly early, impossibly massive galaxies. And the following shows why the expert threw the word impossible around so much. To explain the existence of the galaxies, either the density of matter in the young universe would have to have been 2 to 5 times greater than our models say, or the galaxies would have to have formed in a way that is completely unknown to us. Either way, scientists find themselves in a major dilemma. Both cases require a profound change in our understanding of the cosmos. So far, scientists have failed to provide us with a clear explanation for this unforeseen discovery. The only thing that is certain is that 500 to 700 million years after the Big Bang, there were already 6 galaxies that had 10 billion and in one case, even 100 billion solar masses of stars, and were therefore similar to our Milky Way today. In view of this, it's not surprising that the objects are referred to as universe breakers by the research group. The discovery calls into question what was previously considered scientifically certain. The mass of stars in this phase of the universe is up to 100 times greater than the old models suggest. Until now, Cosmology has assumed that galaxies begin as small clouds of stars and dust and gradually grow larger. But is it impossible that this is not the only way in which stellar associations are formed? This discovery deepens the perplexity of the experts. Well, this mystery still needs to be unraveled in the future. And the next discovery by the James Webb Telescope shows just how essential this will be. The $10 billion device has recently found another new record holder and added another puzzle to the star charts. In the same breath, researchers at the Scuola Normale Superiore in Pisa identified Jade's GSZ 140 as the oldest known galaxy ever. The analysis of the collected data has shown that this gravitationally bound collection of stars and company was formed 290 million years after the birth of the universe. But that's not all. The bottom line is that it probably took around 100 million years to grow to its observed size. And speaking of size, in this case, the researchers were not confronted with the faint baby galaxy that our current models predict, but with a structure that already contained several hundred million solar masses of stars. And once again, the question arises, how could such a bright and massive galaxy have unfolded in less than 300 million years? And why did a further analysis show that the spectrum contains oxygen as well as emission lines of hydrogen? After all, this fact indicates that several very massive generations of stars had already completed their life cycle before the experts examined this galaxy. Well, questions upon questions. But are there any answers? In view of the discoveries presented so far, one might think that each new Webb discovery only plunges astronomers deeper into their scientific crisis of meaning. But that's not the case. Fortunately, there are more revealing answers. How light came into the early universe around 380,000 years after the Big Bang during the so-called Dark Ages. There were no galaxies, no stars, and therefore no sources of light. Indeed, the transparent, neutral space was filled with a dense fog of hydrogen gas. Around 100 million years later, so-called reionization began, in which the hydrogen became ionized and translucent again. This process was literally plausible, which in turn was due to the first very energetic stars that knocked electrons out of the hydrogen atoms. But this is where it gets tricky. The question of where the photons that made the cosmos shine came from has been hotly disputed for decades. Some theories were based on the influence of black holes, but now Webb has lifted the cosmic veil and revealed a glimpse behind the scenes of light in detail. An international research team has discovered that small dwarf galaxies most likely produced huge amounts of high-energy radiation. The researchers tracked down this astronomical trail as part of the Uncover program, which is being carried out with the help of Webb's near-infrared spectrograph, NIR-SPEC, and NIR-CAM. However, making the light of very distant galaxies visible sometimes requires a clever trick. This trick goes by the name of the gravitational lens effect, which refers to the deflection of light by large masses. Basically, the light from a distant source is influenced by an object that appears to be in front of it, the gravitational lens. The following principle applies: the closer the light rays are to the mass, the more they are deflected towards it. In the case of the discovery mentioned above, this means that 8 faint galaxies were made visible through the lens of the galaxy cluster Abell 27 and Abell 44, which normally elude our earthly gaze. The bottom line is that the structures are around 100 times less luminous than the Milky Way, and yet spectroscopic analysis showed that they emit 4 times more radiation than previously assumed. Consequently, astronomers were relieved to announce that they had finally tracked down the ominous photon source that once made the cosmos shine. But before we get it wrong, of course, it wasn't these 8 small galaxies that ionized the universe some 500 to 900 million years after the Big Bang and made it translucent again. They are simply representative proxies. The low-mass cosmic powerhouses occurred frequently enough in the early universe to collectively change the state of the entire universe. And conveniently for us, these objects occur frequently enough in the universe to change the state of the cosmos once again. So, with just one click, join our community now and never miss an exciting video from us again.